Okay, to explain the third part of vertical projectiles, we're going to look at this illustration here. So Lerato throws a stone vertically into the air from the top of the cliff, right? The stone strikes the ground below after 3 seconds. The velocity time graph shows the motion of the stone. Okay, so I've drawn the illustration here. So look at the building where A is. That's where Lerato is standing. Okay, Lerato then throws the stone, sorry, up until the air until it reaches this point B. Okay, the ball comes down, passes the point at this point A, where it initially started, and hits the ground after 3 seconds. Okay, so now what we know now from this illustration is that there will be a time here and there will be a time from that maximum height to the ground. That won't be the same time. Okay, the things that we learned in the previous two examples still apply, as gravity is negative when you're moving upwards and is positive when you're moving downwards. Remember to add this into your calculations, the directions. So you need to add those negatives and those positives in order to get the correct answer. Now, the way the graph is shown to you should give you all the information that you would need if follow-up questions were to come from this. Okay, let's say how long the stone took to fall from the height of the cliff to the ground. The height above the cliff, sorry. Okay, so if you look at this, the stone left Lerato's hand at a velocity of 10, right? When it reached a velocity of 0, it reached that velocity in 1.02 seconds. What does that mean? Okay, this means that this stone, right, to move from Lerato's hand to this highest velocity being 0 when it stopped, that took 1.02 seconds. Okay, then for the stone to move here and come and hit the ground, we go back to the graph. Okay, now the graph says that the stone traveled, right, 2.04 seconds. It reached a negative 10 velocity. I'm assuming that because that time is equal, that is when it equaled the height that Lerato, the cliff that Lerato was standing on, right? Then it took another 1 second for it to reach a maximum velocity of 19.4, right, in 3 seconds. So this means that we would need to take the 3 seconds and minus the 2.4 seconds to actually get the time. So that would mean that time time BC would equal time BC, right? Yes, would equal 2 time A B minus, we need to minus that from the total time. So we know that the travel was 3 seconds, right? So we know that the travel was 3 seconds minus 2 time AP. So we know that 3 minus 2 times 1.04, which will give us 3 minus 2 times 1.04, which would give us 0.92 seconds. So that's the time from this point here to point C. Okay? What you must understand with these types of questions, right? If you look at the graph, the velocity upward on the velocity time graph would be taken as positive, right? So that you can come down to 0, and as the ball or the object accelerates down to the ground, those velocities would be taken as negative. Okay? I think this will help you to plot out your velocity time graph and actually give you an opportunity to also plot out your displacement time graph in the most accurate way possible. The velocity time graph is a straight line graph, okay? And your displacement time graph will sort of follow the parabola because you would need to plot